reactants there, whichever gives you the least amount of the final product is going to be your limiting reactant. You answer that question. You also know how many grams of the product you're supposed to get. Okay, so that's one way to do the calculation there. Another way there is to take into consideration between the two reactants there, and take into consideration of molar ratio. And if it's 1-to-1 ratio, whichever has a smaller amount, it's going to be limiting. If it's not 1-to-1 ratio, well, you have to look into the numbers there. Okay, so another limiting reactant example there. I think I told you I raised chickens in my backyard there. So when we got the chickens back into the house there, and they're so lovely little fuzzy feather balls, but after a couple of weeks, keeping them inside the house, we find out that we can't keep them inside the house because they're always scratching, they're always flap their wings, and there's a thin layer of dust on everything inside the house. So we have to put them outside. And we went to a place along Road 70, I think it was exit 73, Lisbon, Woodbine. There was a place right off that exit there to the south part that sells chicken coops. And we went there, me and my wife, and a 4x6 chicken coop, they charged $1,500. My wife said, no, I got a cheap labor in the house. We're not spending $1,500 to buy a chicken coop. So we got some materials from Home Depot, lumbers and sidings and windows and all that, and we end up with the final product there. And so that's the chick. So that's my first plot there. Okay, so, and this is what I got. But just so you know, after raising the chicken, I almost stopped eating chicken. I can't imagine putting those lovely birds in my mouth there. So as an example of doing limiting reaction there, these are the available building materials that I have there. So I have enough framing for 10 coops. And that, by the way, that could be my retirement project there. And with the profit that I saw in those things there, I won't jump in there because it takes a lot of time for me to build them. I have enough material for framing for building 10 coops there. Roofing for 6, a siding wall for 8, windows and hardware 3. My question is, how the total number of coops that can be built? 10, 6, 8? 3. You can only do 3. Because when you finish the first 3, you will no longer have any hardwares and windows there. That happens to be the case when we were building the chicken coops simply because windows are quite expensive. So we only have one out window from the house when we replaced windows there. So, so the limiting reactant in this case is the window hardware. Okay, and so the idea here is that you will see this particular slide over and over and over again. We're trying to emphasize the limiting reactant is the one that runs out first. It's also the one that gives you the least amount of final product. Okay, that's how you determine the limiting reactant. Going back to the first question that we run in this class here at the beginning. So if you have 19 grams of zinc, well, if you have 21 grams of zinc, but you have 19 grams of hydrogen chloride, which one is the limiting reactant? How many grams of zinc chloride can be produced? Well, in this case, you do not see that word excess. So you have to figure out 19 grams of, 21 grams of zinc and 19 grams of HCl. Which one is going to run out first? Just like when you prepare some more when you build chicken coop there, you need to figure out which one is going to run out first based on the balanced chemical reaction equation. So all we need to do, the first thing that we have here in the given information, we have 21 grams of zinc, 19 grams of HCl. And we are trying to figure out how many grams of zinc chloride, eventually, how many grams of zinc chloride can we get. So based on the numbers there, 21 is greater than 19. So, well, since 19 grams is less than 21 grams, so HCl is a limiting reactant, right? Correct? A smaller number is going to run out first. No. You got to compare the moles. So you have to convert anything that's given to you in a chemical reaction equation when you're doing quantitative calculations there. You have to convert everything into moles. whichever is the smaller number of moles may be the limiting reactant. And we're not comparing the mass here. Okay, so 19 gram is less than 21 gram. We can't draw a conclusion that 19 gram is going to run out. Not necessarily. You have to do a calculation to figure it out. Okay, so in this case, well, we need to do a calculation. Okay, and how do we convert? How do we do calculations? We need to convert zinc to moles, 21 grams of zinc to moles. We need to convert HCl to moles. Okay, now 21 grams of zinc is equivalent to 0.32 mole of zinc. And that's something that we already did. Now, when you convert 19 grams of HCl to moles, there is a number in front of HCl in the balanced chemical reaction equation. You do not, I say you do not factor that in. The conversion factor is 1 mole of HCl is equivalent to whatever grams, in this case 36 grams of HCl. Okay, so this is the conversion factor there. So 2, that 2 is about the molar ratio in the balanced chemical reaction equation. So you don't put 2 in here because each mole of HCl is equivalent to 36 grams. If you put a 2 in here, that would be 72. Okay, because this conversion factor is the molar mass. And the molar mass is the mass for each mole of the compound there. So this is a common mistake that people do, people make when they do questions like this. So, well, there's a 2 in there, so we must put a 2. No. If you put a 2 in there, you have to multiply the denominator by 2 as well in this case. Okay? It's 1 mole of the grams of the sample per mole of the chemicals here. So in this case, 0.52 mole of HCl versus 0.32 mole of zinc. Okay, you say the first thing we need to do is to convert everything into moles. Now everything is into moles there. Zinc has a smaller number of moles, 0.32. HCl, 0.52. So 0.32 is less than 0.52. So zinc is the limiting reactant. Right? You have to take into consideration about the molar ratio here. What this equation tells you, remember it at the end of chapter 3 and the beginning of chapter 4, we're trying to tell you have to understand what that sentence in chemistry is telling you. That sentence is telling you for every mole of zinc, it takes 2 moles of HCl. So if you have 0.32 mole of zinc, it takes 0.64, 32 times 2, 0.64 mole of HCl. You don't have 0.64 mole of HCl. You only have 0.52. So this one is going to run out first. So the question here is that, is zinc is the limiting reactant? Is that correct? No. You have to take into consideration about the molar ratio. If it's 1-to-1 ratio between the 2 reactants, yes. Whichever is the smaller number of moles, that's going to be your limiting reactant. But when it's anything other than 1-to-1 ratio, you have to take into consideration of molar ratio. Well, we can do a calculation and try to find the molar ratio based on the number of moles of each reactant that we have here. Okay, so molar ratio in a given amount is 0.52 divided by 0.32. It's 1.6. The required amount is 2-to-1, not 1.6 to 1. Okay, the required amount is 2-to-1. That means we don't have